Hi guys. Today we're going to go over your mass percentage error lab. And when we do that, we have three learning targets. The first one is we want to learn the term mass. I know we had it in freshman physical science, but we want to review that, make sure you're comfortable with it. The second thing that we want to do, it'll be hard for you to do on camera, but I just want to expose you to everything the students did, is we're going to get familiar with the metric unit of mass, which is the gram. And then the third thing is we're going to calculate some percentage error. So let's go ahead and get started. The first thing is the term mass, okay? And really the difference between mass and weight, because a lot of times we use those words interchangeably, and they really mean two different things. Weight is a measure of the gravitational pull on an object, okay? So it's how hard it's being pulled down by gravity. Whereas mass is the amount of matter in an object. And sometimes they're the same, but sometimes they can be different. Here's the example I use with the students all day. Okay, we're on the planet Earth. I weigh 250 pounds. If I go to the moon, it's got less gravitational pull. So I will weigh much less on the moon, but I still have the same amount of mass. The opposite of that is I go to Saturn. Saturn's a great big planet, a lot more gravity. My weight is going to increase tremendously, but I'll still have the same amount of mass. Typically when we measure weight, we'll use a spring scale, okay? The ones you stand on in your bathroom, they have a little coiled spring that you'll push down on, or like a fish scale you hang up, and it measures how hard gravity's pulling down. When we use mass, we'll use a balance, okay? The little teeter-totter looking balance. And what we'll do is put objects of a known mass on one side. This is 500 grams. This is 100 grams, and we'll put those on the opposite side of the object until it balances. And that way we know we have the correct mass to represent that object. Okay, so those are the different ways we measure them. One good way to think of mass. Gravity only pulls down, but if you guys remember when we talked about inertia, okay, the key thing about inertia was an object in motion tends to stay in motion. An object at rest tends to stay at rest. And that's really based on their mass. So an object with more mass is much harder to get started, but once it's going, it's also much harder to get stopped. Let me show you a little example about that. This right here will oscillate, and these springs have a constant force. Okay, so if I pull this back, they're going to turn it the other way. The object right out here has a mass, and these springs are moving it back and forth. Now, I had my students guess this all day. Some did well, some didn't. But I'm going to increase the mass of the object at the end of these springs. So I want you to kind of think about what's going to happen. Is it going to go faster, slower, or stay the same? Well, here we go. I'm going to pull it back, and it is much slower. Okay? I'm going to add a little more weight. Or mass as we're demonstrating, sorry. So I add a little more mass, I pull it back, and it's even slower yet. And the reason is that these springs, okay, only have so much force. And remember, we said as you increase mass, it's harder to get it started and it's harder to get it stopped. So as I increase mass more and more and more, it was harder for those springs to get that direction changed. The final example I'll use, and I'll move on, is we always said, boy, I'm sitting in the front yard, I'm leaning back, I'm drinking an iced tea, and enjoying watching traffic for whatever reason, and a kid, an out-of-control 2-year-old, comes down the road on the tricycle, veers off course, and hits me. Okay? The next day I'm sitting out there, cruising back, drinking my iced tea, watching everybody go by, and an out-of-control semi comes down the road and hits me. Which one hurts worse? Goofy question. Of course, the semi takes me out altogether, and I got a sprained ankle with a little kid, you know. But that's because of the mass. The first mass, the 2-year-old on a tricycle, isn't going to have a lot of force behind it with that inertia. So it's going to be pretty easy for me to stop it. Whereas the semi, a lot of mass, very hard to stop, and I'm going to have bad injuries with that. Okay, let's go on to the second part. We familiarized ourselves with the mass of some of these. This is a 500 gram mass. Of course, you can't feel it, so if you speak to your teacher, they'll get these out so you'll have a chance to see what these feel like. okay? And the third part was we wanted to calculate percentage error. To do that, we took some objects, some standard objects, and after grabbing these, we estimated their weight, okay? I had all my kids set up a chart that shows the 5 objects, and if you're following along, I'd like for you to do this. So, directly under data and calculations, I wrote the 5 things we're going to use: a foam cube, a brass bar, a copper nut, a rubber stopper, and a CD case. Okay, so now the first thing I'm going to pick up is the foam cube. I feel the foam cube, I'll shake it around a little bit, and I think that weighs about 30 grams. So I write that down. Now the brass bar, I'm going to pick it up and shake it around a little bit, and I think that weighs about 150 grams. The copper nut, I pick up, I shake around, I think it weighs about 15 grams. The rubber stopper, I pick up, shake it around a little bit, I'm going to say about 30 grams. And the last one, the CD case, pick it up, shake it around, I'm going to say, my goodness gracious, 100 grams. So, once I do that, I'm going to get out the scale and see what they actually weigh. Alright, the data that we just collected, I'm putting under experimental. If you did an experiment, your results, you would collect that under experimental. Now, we're going to use the scale and find their true weight, and when we do that, I'm going to give that as the accepted value. So, let's go through and do those same objects again. The foam is 15.0. The brass bar is 142.6 grams. The copper nut is 17.6 grams. The rubber stopper is 21.1 grams. I'm not very good at this. And the last one is the CD case, and it is 70.6 grams. Okay, so we've gathered that data up. The big thing we're wanting to use this for is to calculate percentage error. Now, the way you calculate percentage error is you're going to take your experimental value, okay, that's the one where you felt it and you estimated its weight. Then you're going to subtract the accepted value. Then you divide the total of that by the accepted value, and you're going to multiply by 100. One thing to look at is, this is all going to be in grams for this example, so grams minus grams is still going to give me grams. But grams divided by grams, those units cancel out. So grams are now gone. When I multiply it by 100, I'm just left with a percentage. Okay, we want to follow along our units and make sure we're coming up with proper values when we're done, and that's a good way to do it. So let me go ahead and stick my numbers in there. All right, so I'm going to do the copper nut. Okay, you guys on your worksheet can follow along and you can do the other ones yourselves. So the experimental value, when I felt it, I thought it weighed 15 grams. Then I subtracted the accepted value of 17.6 grams. Make sure you hit total here. A lot of people went 15 minus 17.6 divided by 17.6 and then hit equals. And a lot of calculators will carry out this operation first and they were getting the wrong numbers. So I always go 15 minus 17.6 equals, divided by 17.6 equals, and then multiply by your 100%. When you're done with that, you're going to get negative 14.8%. Now, a lot of people are saying, what about the negative? Well, in years past, we have said if it's negative, don't worry about it. But our textbook and a lot of colleges are now wanting to see if it's negative. So anytime your experimental value is less than the accepted, you're going to have a negative percentage. Okay? If yours is higher, you're going to have a positive percentage. So once we do that, on the back of your page, I'm going to have you go ahead and calculate out the other 4. Okay, find the percentage error on the other 4. Once you're done, set them down there, look back and see which one is your highest percentage error, which one is your lowest percentage error, and write those in the analysis and concluding statements. And then look and see if you can see a trend. Okay, did you do really well on the light ones and not as well on the heavy ones? The ones that had a big area to them. Okay, did you estimate those well, but the smaller ones you didn't? Look for trends and write a statement, okay, that follows those trends and describes them. Good luck with this, and hopefully it's not too hard for you. Thanks.